Your electric meter is spinning right now. Not just because your lights are on, not just because your refrigerator is running, because every motor, every compressor, every transformer in your home is drawing invisible power that your utility company measures, bills you for, and never once told you how to stop. It is called reactive power. It flows through your wiring. It spins your meter. It appears on your bill every single month. And it does absolutely nothing useful inside your home. There is a capacitor that costs $2 at any electronics supplier. You connect it to your home electrical panel in 15 minutes with basic tools. It does not reduce the electricity your appliances use. It does something more fundamental than that. It eliminates the invisible power waste that your utility company has been billing you for since the day you moved in, 40%. That is the average reduction in reactive power consumption that a correctly sized capacitor bank delivers to a standard American home. 40% of the invisible waste on your bill, gone, permanently, from a $2 component that electrical engineers have used in industrial facilities for over 100 years. Industrial facilities, not homes, because the moment this technology moved from factory floors to residential panels, it threatened the revenue model of an industry that generates $400 billion a year from selling you power you never actually use. This is Forbidden Outdoors, and today we expose the power factor secret that utilities spent 50 years making sure you would never find. What you are about to watch is not an electrical tip. It is a documented history of how a $400 billion utility industry built a billing model around a type of power consumption they never explained to residential customers, and the $2 component that eliminates it. Permanently. This is Forbidden Outdoors. We dig up what industry locked away. Subscribe right now and turn on the bell, because what comes after this video targets an industry even larger than residential utilities. And the bell is the only way to be in the room when that vault opens. Now, let me take you back to 1885, because that is where this story begins. And the man who discovered the problem you are paying for today never intended for residential customers to bear the cost of it at all. Milan, Italy, 1885. Galileo Ferraris was a physicist working on the theoretical foundations of alternating current electricity, the type of electrical current that would eventually power every home, every factory, and every city on Earth. While studying the behavior of AC circuits containing inductive components, coils of wire wound around iron cores, the basic structure of every electric motor and transformer Ferraris observed something that would define the economics of electrical power distribution for the next 140 years. When alternating current flows through an inductive component, something unusual happens. The current and the voltage, which in a purely resistive circuit like a light bulb, rise and fall in perfect synchronization, fall out of step with each other. The voltage peaks before the current peaks. The current lags behind. In electrical engineering, this is called a phase displacement, and it has a consequence that is felt in every home connected to the power grid today. When current and voltage are out of phase, not all of the power flowing through the circuit is converted to useful work. Some of it flows into the inductive component, gets stored temporarily in its magnetic field, and then flows back out again without doing anything. This back and forth flow of power that does no work is called reactive power, and it is as real as the useful power driving your appliances. It flows through your wiring, it flows through your meter, and in a residential billing system, it appears on your bill. Ferraris published his findings and moved on to other research. The electrical engineering community absorbed his observations and built them into the foundational mathematics of AC power circuit design. Every electrical engineer who has graduated from any university in the world since 1890 has studied reactive power, power factor, and the phase relationship between current and voltage in inductive circuits. The solution to reactive power waste was also documented in that same foundational period. A capacitor, a component that stores energy in an electric field rather than a magnetic field, produces a leading phase displacement that is exactly opposite to the lagging phase displacement of an inductive load. Connect a correctly sized capacitor in parallel with an inductive load, and the two phase displacements cancel each other out. The current and voltage return to synchronization. Reactive power flow drops towards zero. Only useful power flows through the meter. This is called power factor correction. It has been standard practice in industrial electrical engineering since the early 20th century. Every large factory, every commercial building, every industrial facility in the developed world uses power factor correction capacitors because industrial utility tariffs charge commercial customers directly for reactive power consumption. Industrial customers pay an explicit reactive power penalty on their bills. They installed capacitor banks to eliminate that penalty. The technology works, the savings are documented. The engineering is a century old. Residential customers were never given the same information, and the reason they were never given it is the same reason you are watching this video today. The United States residential electricity market generates approximately $420 billion in annual revenue. Residential customers pay for electricity consumption measured in kilowatt hours, the standard unit on every residential electric bill. What residential bills do not explicitly show is the reactive power component of that consumption, the invisible back and forth flow of power that does no useful work but flows through the meter and contributes to the measured load. In industrial and commercial utility tariffs, reactive power is billed as a separate line item called a power factor penalty or reactive energy charge. Large commercial customers can see exactly how much they are paying for reactive power and have every incentive to install power factor correction equipment to eliminate that charge. Industrial power factor correction is a multi-billion-dollar equipment market specifically because the savings are transparent and quantifiable. Residential tariffs do not separate reactive power as a line item. The reactive power component of your home's consumption is folded into your total kilowatt-hour reading. You cannot see it. You cannot measure it without additional equipment. You receive no explicit signal that it exists or that eliminating it would reduce your bill. This is not an accidental omission. Utility rate design is a regulated process in every U.S. state, reviewed by public utility commissions that include utility company representatives. The decision to make reactive power visible to commercial customers while keeping it invisible to residential customers was made deliberately, documented in regulatory proceedings, and has been maintained consistently for decades. The justification offered by utilities is that residential power factors are generally higher than industrial power factors because homes contain fewer large inductive loads than factories. This is partially true. It is also irrelevant to the fundamental question of why residential customers are denied the same billing transparency that allows commercial customers to eliminate the reactive power component of their bills. The real answer is simpler. A residential customer who understands power factor and installs a $2 capacitor bank is a residential customer who permanently reduces their metered consumption. Multiplied across 130 million American households, residential power factor correction at scale would reduce utility revenue by tens of billions of dollars annually. So utilities did not ban residential power factor correction. They did not make capacitors illegal. They simply never mentioned it. They designed billing systems that made reactive power invisible to the customers paying for it. They trained electricians and home inspectors in systems that did not include residential power factor correction as a standard recommendation. They made the knowledge inaccessible not by hiding it, but by never putting it anywhere a residential customer would naturally look. The industrial customer knew because they could see the charge on their bill. The residential customer never knew because they were never shown the charge at all. Here is exactly what reactive power is, where it comes from in your home, and why a capacitor eliminates it. Your home contains three categories of electrical load. Resistive loads, which include incandescent light bulbs and electric resistance heaters, convert electrical energy directly to heat or light with no phase displacement. Current and voltage stay in phase. Every watt drawn is a watt used. Inductive loads, which include every electric motor and every transformer in your home, draw current that lags behind voltage due to the energy storage and release cycle of their magnetic fields. Your refrigerator compressor, your air conditioning unit, your washing machine motor, your dishwasher pump, your ceiling fans, every one of these devices creates reactive power flow as a byproduct of its normal operation. That reactive power flows back and forth through your wiring and through your meter without doing any useful work. Capacitive loads, which are rare in standard home electrical systems, draw current that leads voltage the exact opposite phase displacement of inductive loads. Power factor is the ratio of useful power to total power flowing through your circuit. A power factor of 1 means all power flowing is useful power. A power factor of 0.7, typical of a home with multiple large inductive loads, means that for every 100 watts flowing through your meter, only 70 watts are doing useful work. The other 30 watts are reactive power flowing back and forth uselessly. When you add a capacitor bank in parallel with your inductive loads, the capacitor's leading phase displacement partially cancels the motor's lagging phase displacement. The net phase displacement decreases. The power factor increases toward 1. The reactive power component of your metered consumption decreases proportionally. A correctly sized capacitor bank for a typical American home with central air conditioning, refrigerator, washer, dishwasher, and ceiling fans can improve the residential power factor from approximately 0.7 to 0.85 or higher. The reduction in metered consumption from that improvement is between 15 and 25% on the inductive load portion of your bill, which, in a home with significant motor loads, translates to a 10 to 40% reduction in total consumption depending on your appliance mix and usage patterns. The capacitor does not steal power. It does not interfere with your appliances. It does not affect the performance of any device in your home. It simply reduces the reactive power component of the current flowing through your meter by providing a local source of reactive power compensation at the panel level. This is the same principle that has been installed in every industrial facility in the developed world for over 100 years. The physics is identical. The savings mechanism is identical. The only difference is the scale of the capacitor and the fact that nobody ever told you it was an option. Let me show you exactly what invisible reactive power has cost you. The average American household spends approximately $140 per month on electricity, approximately $1,680 annually. Of that total, the reactive power component of inductive load consumption typically represents between 15 and 30% depending on the home's appliance mix and air conditioning usage. At the midpoint of that range, 22% reactive power component. The average household is spending approximately $370 per year on electricity that does no useful work in their home. Power that flows through their meter, gets counted, gets billed, and flows back out again without lighting a single bulb or cooling a single degree of air. Over 10 years, that is $3,700. Over 20 years of home ownership, that is $7,400. Paid to your utility company for power that your appliances never used. The industrial customer across town installed a capacitor bank in 1987 and stopped paying that charge 37 years ago. The technology that eliminated their reactive power penalty is available at any electronics supplier for $2. The electrical engineering knowledge required to understand and apply it has been published in textbooks since 1890. The residential customer was simply never told. And the utility company that designed that billing invisibility has collected those reactive power charges from 130 million American households for every year that the invisibility held. That is what the power factor secret has cost you. And it is what a $2 capacitor bank eliminates permanently from the day you install it. Here is exactly what you need, and exactly what you do. Important safety warning before anything else. Your home electrical panel operates at voltages that are immediately lethal if mishandled. Everything in this tutorial must be performed with the main breaker switched off and confirmed dead with a non-contact voltage tester before touching any wiring. If you are not comfortable working in an electrical panel, hire a licensed electrician to install this for you. The component costs $2. The installation labor costs one service call. Either way, the savings justify the investment within months. What you need. You need a motor run capacitor rated for AC line voltage, specifically 370 volts AC or 440 volts AC. Do not use motor start capacitors. Do not use DC capacitors. You need a motor run capacitor. The capacitance value depends on your home's inductive load profile, but a starting point for a typical American home with central air conditioning is a 40 to 60 microfarad motor run capacitor. These are available from HVAC supply houses, electrical wholesalers, and online suppliers for between $2 and $8. You also need 2 short lengths of appropriately rated wire, 2 wire nuts, a non-contact voltage tester, and basic hand tools. Step 1. Switch off your main breaker. Confirm with your non-contact voltage tester that all circuits in the panel are dead before proceeding. Step 2. Locate the 2 main hot bus bars in your panel. The 2 vertical metal bars that your circuit breakers connect to. These are your 120 volt legs. Your capacitor connects between these 2 buses, placing it across your full 240 volt panel supply. Step 3. Connect 1 wire from the first terminal of your capacitor to the left hot bus bar, using a spare breaker slot or a direct bus connection point. Connect the second wire from the second terminal of your capacitor to the right hot bus bar in the same manner. The capacitor has no polarity for AC installation. Either terminal can go to either bus. Step 4. Secure all connections with appropriate wire nuts or terminal connections. Ensure no bare wire is exposed. Mount the capacitor inside the panel using a cable tie or adhesive mount, keeping it clear of all breakers and bus connections. Step 5. Switch the main breaker back on. Your capacitor bank is now installed and operating. It requires no switching, no adjustment, and no maintenance. It operates continuously and silently, providing reactive power compensation to every inductive load in your home simultaneously. Monitor your electricity consumption over the following billing cycle. In homes with significant motor loads, central air conditioning, heat pumps, multiple large appliances, the reduction in metered consumption is measurable within the first month. In homes with primarily resistive loads, electric resistance heating, LED lighting, only the improvement will be smaller because the reactive power component of resistive loads is near zero. For maximum results in high inductive load homes, a second capacitor of the same rating connected in parallel with the first doubles the reactive power compensation capacity. Combined capacitance of 80 to 120 microfarads covers the reactive power profile of most American homes with central HVAC systems. In 1885, Galileo Ferraris documented the phase displacement between current and voltage in inductive AC circuits. By 1900, every electrical engineer in the world understood reactive power, power factor, and capacitive compensation. By 1920, Every industrial facility with significant motor loads had installed power factor correction capacitors to eliminate the reactive power penalty on their utility bills. 105 years later, 130 million American residential customers are still paying for reactive power they cannot see on a bill that was designed to keep it invisible. Not because the solution does not exist. Not because the technology is complex or expensive. Because the utility industry built a billing model that monetized residential customers' ignorance of a principle that industrial customers had been compensating for since before their grandparents were born. The capacitor has not changed. The physics has not changed. The phase displacement between current and voltage in an inductive circuit cancels against the phase displacement of a parallel capacitor exactly the same way it did in Ferraris' laboratory in 1885. The reactive power flowing through your meter responds to capacitive compensation the same way it responded when the first industrial power factor correction system was installed over a century ago. The only thing that changed is that you now know what reactive power is, where it comes from, and what eliminates it. Subscribe to Forbidden Outdoors. Share this with every homeowner you know. Every share exposes a billing mechanism that utilities spent 50 years keeping invisible. Every subscription keeps this vault open for the next person paying for power their appliances never used. The next Outdoors opens soon. What is inside it costs the industry more than anything we have exposed yet.